Yeah, hello. In this video, I want to talk about how to perform a path analysis using R. So path analysis is probably the oldest causal analysis. Okay. Path analysis is an extension of regression that models both direct and indirect relationships among a set of observed variables within a system of structured equations. It allows variables to act as both predictors and outcomes, thus examining complex causal chains, not just single dependencies. The method breaks down effects into direct effects, immediate influence, and indirect effects mediated through other variables, clarifying how causal influence travels through the network. Path analysis commonly visualized using a path diagram where arrows represent hypothesized causal connections, and it serves as the subset of structural equation modeling with only observed, not latent variables. So it's a special case of structural equation models. Applications span psychology, social sciences, healthcare, marketing, and more, making it valuable for understanding real-world multi-step causal processes. Okay, now let's go through the R codes. First, let's generate the data set. Set a random seed, sample size 200, generate attitude, norms, and control. And then the relation attitude is 0.5 plus norm plus a random error. And the intention is 0.3 times attitude plus 0.3 norms plus 0.2 control plus a random error. Okay, and this put together as a data frame. This is the first few rows of the data set. And we're going to use the structural equation model packaged in our lavaan. And we specify the model. So model is attitude, regress on norm, intention regress on attitude, norm, and the control. Okay, and that's it. Okay, and then we're going to fit the model. And syntax very simple, SEM model data equal to DF. And here's the summary. It's a lot of outputs here. First, you see the summary. So the lavaan 0.6 to 19 ended normally after one iteration. Okay, so it's estimated maximum likelihood, optimization method, NLM, IMB, and the number of model parameters 6, number of observation 200. You got the model test, user model, model test baseline model. You got the test statistics. The p-values are 0.5379. That's pretty good. There's the model and the data matches pretty well. And the baseline model is very different. So you need plugging all the models. And you got the comparative fit index CFI 1.0, which is pretty good. Usually, if it's above 0.95, it's an excellent fit. Okay. And you get the TLI, the Tucker-Lewis index, as 1.016. This is, yeah, I think also pretty good index. And you don't have the other. You have the RMSEA, and also the 90% confidence interval lower bound, and this is approximately 0, so it's a value below 0.6 are good, and also the SRMR, this is the standardized root mean square residual. It's indicate minimal differences. So these are all looking pretty good. Okay. And then you got the regressions. You look at the um, regression called the loading factors. They're all positive. So meaning from that equation, you can see how they influence the dependent variable. So they're all positively influencing the dependent variable. And also the p-values are very small, so they're all statistically significant. And the variances, they reflect, um, you know, the residual variance, which is unexplained by the regression. So here the p-value is 0 for both intention and other variable can see, but they're significant. So that means the given model did not explain all the variability. Okay, so that's kind of a quick going through of the outputs of that path analysis. Okay. All right. So usually we generate a path diagram using SEM. This is another package, and semPlot. Okay. So once you load the SEM package here, it's gonna mask the SEM function in the lavaan package. Okay. Uh, and to generate the path diagram is pretty simple using the function SEM paths. Okay. This give you on here give you the path diagram. You can see from um, the attitude, to intention, etc., etc. Okay. All right. So this is a pretty simple but direct example of a classic path analysis using actually R package for structural models. Okay. There's a RPack for the path dot analysis, specifically for path analysis, but I try to install it. It requires like so many dependencies, and so I eventually gave up. I just let's take the shortcut, just using the structural equation model packages to do a path analysis, because path analysis is a special case of structural equation models. All right, thanks for watching.